In this video, we'll look at naming alkenes, including cycloalkenes and alkynes. So we'll start with naming an alkene. So there's an alkene drawn on our page here. When we're naming an alkene, our parent chain must contain the double bond. So our parent chain must contain that double bond, and we're going to find the longest continuous chain, which is here. And so our parent chain is going to be 1, 2, 3, 4, 5, 6, 7. So our parent chain is heptene. And in this space, we're going to put the location of the double bond. And we'll number this. We'll go through how you number it in a second. Now we're going to identify our functional group, so our branches. So we have this branch here is an ethyl group, as is this branch, so we'll have 2 ethyls. And lastly, this little branch up here is a methyl group. So our name before we add any numbers is going to be alphabetical, same as alkanes, so it will be 2 numbers, so the 2 locations of our ethyl, so 2 numbers diethyl, and then some number methyl, hept, and then the location of the double bond, ene. So now we just need to figure out our numbering scheme. So in this we could do 2 numbering schematics. We could go from left to right, which I'll number in blue, or we could go from right to left, which I'll number in purple. So we're only going to pick one of these. When we're naming or numbering a double bond, or an alkene, sorry, a compound with a double bond, we want the lowest priority or the lowest number possible to go to our double bond. Okay, so if we look here, our double bond is given priority. So what that means is going from left to right, our double bond is on carbon 2. Going from right to left, our double bond is on carbon 5. So 2 is better than 5 in terms of priority. So we're going to use our left to right numbering modality. So hept2ene. Our ethyls are on 3 and 5, and our methyl is on 6. Okay, so now we're going to go through naming of a cycloalkene. So again, we're going to start by looking at our parent chain. So I'm going to highlight that in yellow. So our parent chain is going to contain our double bond, and the name of that parent chain is going to be cyclohexene. We do not need to include a number for the double bond because that double bond is always between carbons 1 and 2 when it's in a ring. So because it's given priority, the double bond is between carbons 1 and 2. So now we're going to look at our groups. We have 3 groups. First group is a methyl. Second group is an ethyl. And our third group is a propyl. Now when we're numbering our cyclohexene, we know that our number 1 carbons, I'm going to just put little dots, so either this carbon or this carbon will be number 1. We're going to look at both directions and see which way is the lowest sum for us. So I'm going to start by going clockwise. So I get 1, 2, 3, 4, 5, 6. And so if I'm going clockwise, my sum is 1 plus 4 is 5, plus 5 is 10. Now if I go counterclockwise, and I'll do this in red just so it's a little bit more clear, and I start at this 1, 2, 3, 4, 5, 6. My sum is now 2 plus 4 is 6, plus 5 is 11. And so what that tells me is that I'm going to be numbering in the clockwise direction, so I get the lowest possible sum. So my name is going to be 5 ethyl, so in alphabetical order, 1 methyl, 4 propyl, oopsies, dash for propyl cyclohexene. And our last example is going to be naming an alkyne. So in an alkyne, same thing. We're going to give preference to our chain containing our triple bond. And so this is a one, so I'm just going to put little X's where the carbons are just for clarity. So there's a carbon here, here. So around a triple bond, there's always a linear Vesper shape. So that's why we draw it this way. And so our parent chain has 1, 2, 3, 4, 5, 6, 7 carbons. So our parent chain is hept, and then the location ine. We have one group on our chain, and that's here, and that group is a methyl group. So again, our triple bond is going to get priority in numbering. Okay, so triple and double bonds get priority over groups, over branches. So we're going to number to give that triple bond the lowest location it can have, which is going to be going from the left side. So we're going to be numbering from the left, 1, 2, 3, 4, 5, 6, 7. And we will get 6 methyl hept 3 ine.